Hello, I'm going to be showing you how to use the Behavior Composer to build an agent-based model. The model is based on this paper by Thomas Schelling called Dynamic Models of Segregation. And notice that he wrote it in 1971. This is probably one of the very first agent-based models. And if you're wondering who Thomas Schelling is, you Google him and you find out he won the Nobel Prize in 2005 and has done quite a lot of interesting work. So let's go to the Behavior Composer. So here it is inside the browser, and from the browser we're going to be able to build a program that gets sent to the NetLogo agent-based modeling tool. So if we go to the composer, we see there's a prototype, and a prototype in our case, in this model, is going to be a household, because we're talking about households and people moving around. And in Schelling's model, there's two kinds of families or households, and we'll just call them red ones and green ones. So we'll get a micro behavior, a little behavior, and this one would set the color of our agents to red, but we want is to randomly choose between red and say blue. So we'll add this to our prototype. Now, this isn't much of a model, but even at this stage we can just send it to NetLogo. And if we hit setup, there we see red, red, blue, blue, red, red, blue, blue, red, red, blue, blue, red. Alternates, or randomly choose between. So let's go back to the Behavior Composer. And it'd be nice to have more than one agent, so let's have 400 agents. And now we send this to NetLogo, and we click Setup, and there they are all at 0, 0. And if we click here, we see we could look at the state of any one of these. So we should try to figure out how to spread them out. So if we go back to the library of different micro behaviors and we search around, we find that here there's a behavior called jump to any unoccupied location. And it does a little bit of work trying to find out a location where there's not any objects that are there and so on. So let's take this and just add it to our prototype and try again. And now when we look at the NetLogo model, here we've got a population of red and green households. Every time we click setup, we get a different one, but in both cases just randomly selected whether they're red or blue. So now let's get to the crux of Schelling's model. So Schelling was interested in how the dynamics of segregation could occur, and how it might even occur if everybody is relatively tolerant. So the idea is that people are going to move if they're not happy, and they're going to, the way they move is to move to an empty place. So we could reuse this one, make a copy of it, just add it again, and then we're going to rename it because it's not going to be the same concept. It's going to be move if unhappy. Okay, so first we need to make this conditional, so we click on it and we say we want to enhance it to be conditional. And the condition that we want is if the number of neighbors that are different is greater than the total times the fraction that you're willing to live with, which we'll call my threshold. Now the computer doesn't know what total or different my threshold are, so we're going to have to define those. So we'll add some variables. So the total is just the count, and the way NetLogo works, it uses the word turtles here, neighbors. So how many agents are on neighboring squares? And then we need a behavior a variable to say what are the number that are different. And that's going to be similar to this, so we'll copy and paste it. But we need to restrict it to just those whose color is not equal to this color. Now you might wonder what this color is. Well, let's go define it. And this is one of these strange things that happens when you do programming. You say this color is color. And what's going on here is the color here is the color of one of the agents on one of the neighboring patches. Well, this color is the guy who's considering moving. So if we didn't make any mistakes, we've got the right behavior. But we want this to happen on every tick of the simulation, and we don't want it to happen on the very first one, so we'll delay it by one. And now, if we send this to NetLogo and try it out, everybody's moving all the time. Nobody seems to be happy. And the reason is we forgot to say what the threshold is, and NetLogo works in such a way that if you don't tell a value variable, it assumes it's 0, so therefore if any neighbors are different from you, you're going to be unhappy. So we need to find a behavior that will define an attribute, and here it is. So we say my threshold, and we'll set it to 7, so that basically means people are happy if up to 70% of the neighbors are different from them. So they're pretty tolerant of being in a mixed neighborhood. So we'll add this to our prototype. And now if we send the model to NetLogo, do a setup, very quickly everybody settles down, and notice that the neighborhoods are relatively segregated. And if we set up again, it's random, and with a few clicks of the ticks of the ticks of the clock, it's random. I mean, there's neighborhoods that are much more segregated than before. So random, and then they move. And one could go much further with a model like this. You can start to explore what happens if people have different values for my threshold, or if they have different ideas about where to move to, not a random place, but maybe a place that has the most people like them, and explore how much this could change. You could put in behaviors that'll make nice graphs or monitor certain measures, but I think that's enough for today. And encourage you to visit modelingforall.org, where you could try the Behavior Composer yourself, and you could even install a tool that will connect the browser with NetLogo so that you could more easily build models and explore things. And there's quite a lot more one can do. So I hope you visit and enjoy. Bye.